Hello everyone, welcome to day 8 of Thapar Summer School, and today we'll be looking at some mini projects. And before that, I would like to share the daily resource with you all, that is PyPy. So guys, PyPy is a repository where you can find different packages for different purposes. They are contributed by people like you, people like us, who daily build projects based on Python, and that can be used by everyone. So a basic example we can take is text to audio module. You just search text to audio and here you can find different modules contributed by different people. They all are based on Python usually. So we'll pick anyone. As you can see here, first of all, you'll find the basic command that can be fed into the command line to install the package. And then you can import that package basically in your Python script or Jupyter notebook. So whenever you look for a package in PyPy, you have to see that a proper project description with a proper manual and commands is given. As you can see that this module has no proper description given, so you'll not be able to use it efficiently. How will you know what functions you have to use, what commands you have to use under that module in your program? So we'll look for another one. Like this one. See, here's a proper project description given. This also authenticates that it is contributed by a skilled person who have given proper instructions that how to install it and how to use it. Here are different functions and different arguments that you can pass while using it, and with an example code also. So let's look for another one. So what if we have to download multiple images from Google? See, you know, build one by one, and it needed tedious tasks. So people have built modules for that too. Yeah. So Google Image Downloader. As you can see that this is a Google Image Downloader. Again, it has no proper project description, so we'll not be using this one. Yeah. So you can see this one. This uses Beautiful Soup Library. We'll cover it in our today's session. This has proper examples how to use it and how to download images using this package. So guys, I would like to advise you to use PyPy packages in your daily projects. And so that was it. Now we'll be looking at the mini projects. Raghav, over to you.
Thank you, brother. So from now, I will take over from here. So let's start with the first mini project, that is image to audio. So this is my repository, and please download this image, that is picture1.png, as we'll be needing. So open this notebook in Colab. Connect to the server and upload the image in the file section. So let's start executing the cell. So first you can see that we are installing the following libraries. And for that we use the command pip install. So pip is the Python index package. And as Pratham already told you about the PyPy, so pip install is the command to download these packages from pypy.org. And just make a note that whenever we install these packages on a virtual machine or like Colab, we include this exclamation mark. So please execute this cell. And some of you may be wondering what is sudo apt. So just like PyPy, sudo apt is also a repository. Just the difference is that some packages are not Python packages; they are system level packages. So we use sudo apt to install them. Let's just wait for this to get installed. Okay. So moving on to the next cell. Here we import those packages. So first we import PyTesseract, we import image and GTDS. So first of all, we open the image that we just uploaded. Sorry, I forgot to run this cell. Okay. So first of all, we open the image that we just uploaded. And next, we use the PyTesseract module. PyTesseract is basically a OCR module. OCR means optical character recognition, and it is used to extract the text from the image. So here we use this module to extract the text from the picture we just uploaded. And after that, we use the GTDS module, that is Google Text to Speech. This module converts the text into the speech. So let's execute this. So you can see that the module has extracted the text from the image. Let's take a look at the image. So this was the image, and you can see that the module is very accurate in extracting all the text. And finally, we get an audio of the same, which you can find here in the file section. Please download it and listen to the audio file, and so that you can verify the text. Okay, so does anyone have any doubts? So let's move to the next project. The next project is a web crawler, and in web crawling, we'll be scraping emails from website. So for that, please open this package.ipynb. So this package, email crawl one, was made by me, and I have uploaded this on PyPy. You can go on PyPy and check there. So as you can see, this is only a 4-line program. So this is the benefit of having a package. So this makes a task easier. We just have to install the package, import the function, and give it the parameters, and our task is done. So let's start by executing these cells. So what this email function does is we give it the sitemap of the website from where we want to scrap the emails, and then we give it the number of emails that we want to scrap. So let's execute this cell, and you'll see a progress bar here. So the total number of websites on hopper.edu is 4342, and our program is one by one searching over those websites and extracting all the images that it can find. So let's just wait for this to do its job. After this, I'll also be showing you the backend code for the same package. Okay, so the execution has completed. let's view. So go into the output file and download the CSV. So I converted all the emails and put them into a CSV file so that it would be easier for us to view it. So you can see this is the CSV that we get, and these are all the email IDs that we found on thapa.pd. So as you can see, we have almost more than 100 emails that the program has scraped.
So you can see that here Raghav has done a wonderful job from just 4 lines of code, and it was all because of PyPy packages. So guys, you can see that PyPy packages played a major role in Python coding as stopping the backend. So using this, you can create different projects. Like for example, this project, this specific project can be used for you to like this will help you in code emailing. Like you are accessing the website of IT Delhi. You have to code email professors from IT Delhi for internships. So you can use this particular project for finding emails of different professors across the globe, which will also help you in getting the mail IDs of different marketing leaders from different companies, and you can connect to different people using this ID for just like for your internships. So there are many different use cases of this. You can also find contact numbers and all. Now we'll look in the backend of this code, and you can relate to with more use cases of this code, like phone numbers and emails and many different things that you can just web scrape using these codes. So Raghav, you can continue.
Thank you, Pratham. So let's move to the backend code of this package. So please go back to my repository. And open this notebook, web crawling empty.ipy. So as you can see here we installed 4 modules, and I embedded these modules in my package. So when we installed WebCrawl1, these packages got installed automatically. So as this is not a package, we'll have to install them individually. So let me tell you about the functions of all of these packages. So request-html will be used to gain access to the information that we have to scrape. Pip install RE. RE is regular expression, and this is the module that we'll use to tell the program that what an email looks like, so that whenever it recognizes a pattern of email, it will scrape that. Pip install request is a module similar to request HTML, and it is also used to get access to the data. Pip install BS4. BS4 is Beautiful Soup, and this is a library that is used in web scraping. So in the second cell, we import all the libraries, and you can see here in the third line, I've used email underscore regex. So this is where we use the RE module, and this is the expression about how an email looks like. You can see although this expression is too long, but this is a unique way of representing an email. So I've told the program that what an email looks like. For example, that it will include a name, it will include an @ sign, and it will include a .com, .in, or .edu. So moving on, this is the cell where we extract all the links from the sitemap. So as you can see, we request the URL to get access to the data, and then we declare a variable links underscore ARR, which is a list. And then we extract all the websites from the sitemap and then append them into the list. Here we call this function and input the sitemap of the website that we want to scrape. Next, we start an HTML session. This is used to scrape data, and as the session starts, we'll be able to access the data. Now I have initialized the variable email that is a set. I did this because I was seeing that a lot of emails were getting repeated. So I initialized this as a set. Now what we do is we take a website from the list that is links underscore data underscore ARR. We started session and then we use email underscore regex, that is the unique code for an email, and we compare all the text data that is present on the website. And as soon as the program finds that a pattern similar to email underscore regex is available, it scrapes it and adds it to the email, which is a set. Let's keep executing all these cells. So you can see that the program has started scraping the emails. And as this is not a package, I have not given it the parameter about how many emails we want to scrape. So this will keep on running until the website detects that a bot is accessing the data and it blocks the bot. So let's give it a few seconds to run. So let's stop this cell manually by clicking on this stop sign. And now we will convert all those emails that we got from a data frame to a CSV file. And you can see in the file section that we got a emails.csv similar to the previous program. Now, if you try and what if you don't stop this execution? So as I already told, the websites have security protocols, and whenever they detect a bot, and so they try to stop it by removing the access. And this program does not work on all the websites because some websites that are advanced, they use security protocols. We do not allow bots to scrape the data. So you may not be able to scrape data from all the websites. And one more point, some of you may be wondering that where do we get the sitemap of a website? So what we do is we just add /sitemap.xml at the end of the website and we get a sitemap. For example, let's go to Thapar Summer School. As you can see, this is the sitemap of thaparsummerschool.com. This is what an XML file looks like. And here we have only one web page. So if we try to scrape it, the program will load this web page into the program and scrape any email that is present. So if you guys have any doubt, you can ask me, or we can move forward to the next step. Project.
Can you show the regex part again?
Okay, sure, Pratibha. So this is the regex path, and as I told you, regex is regular expression. So what regex does is we have assigned a unique variable to every alphabet or symbol that we write in English. So what this does is this tells the program that what the specific string looks like. So what I've done here is I've given the program that how an email ID looks like. So you may not be able to understand this from here, but you can go to your browser, and from there you can check how to write a string in regular expression. And one more point for your information, we can modify this from here, this regex, and then we can extract whatever you like. For example, we can extract phone numbers from LinkedIn or job postings, names of professors, anything that you like. So moving on to the next project. So the next project is audio to text. So please download this 01.mp3. Please download this 01.mp3 because we'll be needing it in the Python node. Please let me know when you are done so that I can continue with this project.
So you can start with it.
Okay, so what we do in this mini project is we convert audio to text. So this is a speech recognizer project, and for that we install two modules, speech recognition and PyDub. So this is also a way to install two modules without writing them in separate lines by just giving a space between them. So speech recognition is the engine that is developed by Google, and PyDub will be used to reprocess the audio file that we'll be using today. Please execute the cells. And if you were not able to upload the audio file, please execute the cell and you will get a prompt to upload it. So what we do here is we convert the MP3 file to the WAV format because the project, the module that we are using is compatible with only WAV files. So please execute this cell and this will give us an output called WAV_file.wav. Please refresh this section. Yes, you can see that we have got this file. So let's move to the main function. So what we do here is we initialize the recognizer and then we define a function called get audio transcriptions. Just a second. Okay, sorry, my runtime got disconnected. Let's continue. So what we do here is we initialize the speech recognizer engine and then we define the function get large audience transcription. And then what we do is we open the audio file using PyDub. This is the syntax for the same. And in path, we'll give the part to the WAV file. Then what we do is we split that file into chunks depending on the silence in between audio. So what we do is we initialize here parameters that will tell the program about how much, what is the threshold of the noise of the silence, and how long, for how long the silence should be there to cut it from there. So we cut this single audio file into chunks and add it to a new folder called audio chunks. And we'll use these audio chunks to process this data further. So please execute this cell. And here you can see that os.mkdir, which is make directory, is used to make that folder. So if you refresh it, you will be able to see that folder after you run the cell. Moving on, so what we do is one by one we open those audio files that we just cut and we listen to them and try to convert it into text. So you can see that I have also used exception handling here because I was getting some errors, and to handle them I use this. And after we execute this, you'll see that we get the text that was we'll get the text that has been converted from audio file. So this is where we give the part of the audio file and then we call the function. Let's just wait. Let's just wait for this to get executed. So you can see that we have started getting the text. So you can verify this by listening to the same audio. And if anyone has any doubts, please feel free to ask me.
So guys, you can also see that you can use this project as a text summarizer. Like you can record your lectures and record your meetings and then convert them to text and then keep them somewhere with your notes, and or you can use it to make notes basically from your lectures. And there are many different use cases for this project also. And I would like you to rethink over these projects and use them in your daily life.
Thank you, brother. So let's move on to the next mini project. So let's continue with the next mini project, that is plagiarism checker. Please download these three text files, Arthur, Ben, and Clark, and open this folder. From here, open this notebook and open it in Colab. Please let me know when you're done uploading. Okay, so let's start. First, we import these three modules that will be used in our program. And you can notice that here we did not install these packages. This is because these three packages are already pre-installed in Colab. So we just have to import them. And I'll tell you about the function of these packages as we proceed. So first what we do is we make a list of the directory in which we have uploaded the files. So what we do is we tell the program to make a list of all the files that end with .txt extension. So let's execute this cell. So student underscore files is now a list of these three files. This makes it easier to access them in the next section. So next what we do is we open these three files one by one and copy the text data in student underscore notes. Now you can see that we have defined a function called vectorize. So let me tell you what a vectorizer is. In our further sessions, when you learn about machine learning and deep learning, you'll notice that the machine learning models can only take input of numeric data. And in order to train them with textual data, what we do is we use a vectorizer. So what a vectorizer does is that it converts the textual data into a numeric format. So in the backend, it uses a mathematical function, and then with the help of that function, it converts the text into a numeric and gives it a numeric representation. Similarly, here we use a vectorizer that is called a TF-IDF vectorizer. So it will do is we will give it the text input and it will give us the output in numeric form. Next, what we do is we define a function called similarity. What this function will do is this will use a mathematical formula called cosine similarity. So what cosine similarity does is that it finds out the similarity between two vectors. So here we'll give doc1 and doc2 as the two vectors, and this will be used further to check the plagiarism between the texts. Please execute this cell. You can learn more about vectorizers and cosine similarity using resources from the internet, or you can also ask me about this after the session. So next what we do is we call the vectorize function and give it student underscore nodes. So just for your clarity, let me show what student underscore nodes looks like. So you can see it is a collection of all the three text files that we just uploaded. So we give it the input of student underscore nodes, and the vectorize function returns us the numeric form of this text data. So what we do next is we make a list of this vector, and that will be used in the next section to pass it to the cosine similarity function. So moving on, here we define a function that is check plagiarism. So what it does is that first of all, we define the s underscore vectors variable as global. So s underscore vectors is the list that we defined here. What it does next is it makes a copy of the vector, and then one by one we access it using index, and then check the cosine similarity between them, and then we delete the current index. So why we do is because we want to save memory. So this is also one way to save memory if you are low on processing power. This is somewhat similar to the pop operation that we do in stack data structure. So what we do next is we extract two vectors from new underscore vectors and then pass them into the similarity function, which gives us the sim score. Sim score is the similarity score. And also, if you have any confusion, you can read the comments that I have given them. So next, what we do is, as the text data has similarities, therefore it means that it would have words that are similar. And to prevent duplication of words, we use the function sorted that will sort all the words and then will remove the duplicate. So next what we do is we create a tuple with student file's name and similarity score so as to display them in the last section. So here we add the score to plagiarism underscore results, which was a set. As you can see here, this was a set, and we return this variable. So here we use a for loop to check the plagiarism, and then we print the similarity. So the similarity we can see, this is what the output we get between Arthur and Clark. The level of plagiarism we get is 0.54, which is 54%. Similarly, between Arthur and Ben, plagiarism is 45%, and between Ben and Clark, it is 40%. So this is what teachers use to detect plagiarism in the assignments submitted by students. There are more ways to do this, and cosine similarity was one of the easy ways to do this. And you can explore other functions. Also, Google Classroom also uses this type of method to display plagiarism. So if you have any doubts, you can ask. Okay, so let's move to the next mini project. So please open the mini project 09, that is QR code generator. So let's start. What we do is first we install two packages called PyQR code and PyPN. So what PyQR code does is it converts the link that will give to a QR code, and PyPNG will convert that code into a image, that is PNG. So we import the PyQR code module. We give it the website whose QR code we want to generate, and then this is the function that will create the QR code for the same. And after this, we use qr.png, that is the function of PyPNG, and this will convert it into an image that can be scanned by a camera. Let's execute this cell. And here I have used the website of Thapar, that is thapar.edu. You can see that in the file section, you will get an image. So you can see here we have a QR code, and if you try scanning it, it will redirect you to the thapar.edu page. So this too was done by using a module. So that's why the code was so easy. And some of you may be wondering that ये तो बना बनाया code है इसको चला के क्या फायदा? So this is just for your understanding and just as to keep this session interesting. So once you try and implement this code by yourself, you will understand how this works. And also we have chosen easy projects, so it is easy for you to implement them. And after implementing this, you can move on to more advanced projects.
So yeah, as Raghav said, that these projects will help you a lot in bigger projects. Like in different hackathons, you can integrate these bigger projects into your codes. That can also help you improve your ideas in your hackathons. So these are really important, and please see to them.
And in the next session, next week, that is based on web development, we'll be using these codes in the backend and using an interface, and then we'll integrate them. So that will give you an idea about how an end-to-end project is made.
Raghav, can you show the home page? Yeah, so guys, today we are over with the mini projects, but there are some more projects for you to see, and these are made by Mr. Basavraj. He's a final year student. You can contact him and ask your queries, and you can ask him about his experiences and your particular doubts regarding placements and all. So you should go through them, and these are easy projects. Like we have also seen Google Image Downloader, a Python image to text OCR, but using the PyTest like OCR, we did that. So these are the projects, and you should see them. Like you can see that cosine similarity usage. Snowflakes was a really good project built by uh, Basabal Bhaiya, and you should see that how he used cosine similarity for movie recommendation system. You all guys use Netflix, Amazon, we get movie recommendations. So similar concept like cosine similarity is being used there. And now coming over to the assignments. Yeah, so guys, today you have four mini projects or your assignments, and you have to submit them by tomorrow. So these four projects have converting 100 images to grayscale, resizing 100 images to 50% smaller size using OpenCV, and converting color video to grayscale and resizing the color video to 50% smaller size. So these projects will help you to understand the concepts of image processing, and you can also use that for pre-processing computer vision data sets. Later on in this very particular course, you'll also participate in Kaggle competitions that consist of OpenCV, that consist of computer vision problems. So you can also use them there. And you can also build services from this basic projects. Like we have covered now 10 to 15 projects. If we talk about all of them, you can build a very easy, open, easy to use internet service out of them. You can build a simple front end and integrate them in the back end and give it to a college or give it to some faculty for usage. You can also contribute the packages on Pi5 and modifications and make them. So these can also add like a source of income to you guys. Like in colleges, you can have very less effort on these. You can put very less effort on projects and make money out of them. So you can do it on the internet, and you can like for example take a simple project Google Image Downloader that can be used as data set generator. So anyone can visit your website and you can ask them for like 100 or 200 rupees, and you can build a data set for them. Like someone wants a data set of bikes, so you can give them like 2,000 images of bikes. You understand? And many different projects like image to text to audio. That is also a very good image captioning process. Like that can be used to teaching. That can be used for teaching purposes. So like these, you can deploy all the projects and make money out of them. Make your own cooler version of them. So daily task also is very important, guys. Like I personally like the one page writing very much. Like you will read research papers and get to know a lot about the current scenario of machine learning and current scenario of technology, what is going on, and also you read concepts. And 5 points of today's learning. Basically, if you write 5 points of today's learning, you will revise the whole session easily. And moreover, those 5 points will also help you in the future. Whenever you read all the 5 points of all the lectures, you can easily revise the whole course in an hour or two. And also explore the audiobooks provided by Chancellor and the generative AI tool and two interview puzzles and one any activity that you love. So this is very important, guys. Please do that, and you should do that by 20 midnight. Thank you, Rahul. That's all from my side.
Thank you, Pratham. Thank you, everyone. That's it for today's session, and we'll meet tomorrow in our next session. That is on machine learning introduction.